So friction is a kind of a force, guys, no? Class, no? It's a force that is present, no, in a body that is pressed on a surface. No? So it's one of the many contact force. I think now I will consider it as a contact force. And when I say contact force, it's a force that needs, no, an actual touch. No? It has to be, no, in contact with another body. No? Now we can actually, no, think of forces in two different kinds. No? So one type of force is contact forces. Another type of force is another set or group of forces are called non-contact forces. No? And when we talk about contact and non-contact forces, no, we can separate forces in that way. Now, one thing that I could give as an example for non-contact forces, examples of this are magnetic forces. No? Even if they are at a certain distance, you don't actually touch an object. We can literally, you know, experience a force because of this. No? So it acts at a certain distance, including gravity. No? Gravitational force is also considered as a non-contact force. No? So once a body comes in contact or at a certain range, no, where it is effectively, no, influenced by the Earth's gravity, then the Earth's gravity will eventually, no, pull that body down, no, towards the Earth. No? So gravity acts at a certain distance, no, or influence, and any object, no, that comes within that range, no, will eventually, no, be pulled, no, towards the Earth. Napaged ang iba. Now, what are other non-contact forces? Electrical forces. No? So you'll see that at a certain distance also, no, some electrical force, no, a repulsion, an attraction can also be experienced. No? And usually this is experienced by a charge. No? If you put two charges together side by side, no? And by charges, I would say that it's a positive or a negative charge. No? So again, no, non-contact forces are those, no, magnetic, electrical, and including gravitational forces. No? Now, for a contact force, no, so when you want to move an object, you will actually push it. No? You have to hold the object. No? So you either push it or press it, no? Or you have to maybe use a string and drag it along. No? So a push or a pull is also considered as a contact force. No? So again, no, in order for this force that we are trying to describe here not to be considered contact, no, then there must be a surface where this friction force is present. No? So talking about friction. No? So moving along, no, we can literally, no, have locomotion. They call it locomotion or movement. No? We can make a roll. No? When we are in our bed, no? We are able to roll, no? Change position, no? Because of this force called friction. No? Maybe your body, no? And the bed where you are lying, no? There's so much friction there that when you try to change position, no? You are able to do that. No? Now, if you will simply slide, no, and will never make it, no, then maybe, no, there's no friction at all between your bed and you. No? In the same way, now this is a foot here that you are seeing. You're able to travel from point A to point B, no? Primarily because your shoes, no? The shoe that you have and the floor or the cement where your foot is on are having this force, no? When they are in contact, no? And thereby, no, it allows you to move from point A to point B. No? Imagine if the soles of your shoes, no, will simply slide, no, and will never actually, no, make you move forward. No? So if the floor is slippery, too slippery, no? So if it's wet, no, like it's a tiled floor, it's filled with some liquid there, it's wet, no? Then slipping or, no, sliding could occur, no? And movement, no, may most likely be very, very difficult, no? Because again, no, we reduce or we made friction, no, very, very small. No? But when there's too much friction also, no, you'll notice that your shoes here, no, will also, no, wear out, no, much more easily, no, if there's too much friction. No? So if you regularly walk, no, you'll notice that it can also, no, make, no, some, or literally, no, damage your shoes, no. So friction is, no, found probably, no, in every surface. You could not say that it's only found, no, in rough surfaces, but it's literally found in every kind of surfaces. No? It's quite impossible to say that since the floor is smooth, no, that there's no friction there. No? So it's found in every surface, no? And the surface is actually, no, when you try to zoom in on the surface, no, try to use ano na, a microscope, no, try to even just try to look at, no, some edges of a smooth ruler, guys, no, on a microscopic level, no, like zooming in, no, the lens of your microscope, you'll notice that it's not really very smooth, no. A ruler that is made of plastic, no, will literally appear, no, in a microscope to be very jagged edges, no, very rough edge, no, because you magnify the surface. No? So literally every surface is actually, no, on a microscopic level, no, zooming in on the surface. It's impossible to be very smooth. No? So usually now these irregular surfaces or these rough surfaces tends to provide us, no, with greater amounts of friction. Okay, now so these surfaces on the other hand, no, allows us also to be able to move. No? So that's one good thing that we derive from friction. No? Friction, no, is advantageous, and, no, at the same time, no, maybe also disadvantageous, no, to some level. No? So again, no, if we will try to look at, no, this box here and the surface, no, using our naked eye, no, we will see that it's literally, no, flat or maybe, no, very smooth, no. But if we try to zoom in, no, on this very small encircled portion, if you try to zoom on it, no, several hundred times more, no, then you'll see that the surface actually there is not smooth. It's very rugged. No? There's this jagged edges here, no, and then when these jagged edges interlock, no, when they interlock with one another, then that's where we see now that when you try to drag this object now, you will have a difficulty dragging it, no? Because these jagged edges that are interlocking with one another, no, prevent you from pulling, no, or pushing it, no, easily. No? So again, on a macroscopic scale, no, we have this jagged edge present. No? So friction is present again, no, in every kind of surfaces, no, and they provide some good things, no, to us, and, no, maybe, no, also, no, when it's too much, no, then there are also disadvantages to it. No? So frictional force plays an important role in mechanics. No? So for our motion, no, for locomotion to happen, no? For objects that are we expect, no, to be, no, stationary. No? So we have a car, for example, no, on the road that has to, no, not to slide. No? So parked cars has to remain where they are. No? So there must be a lot of friction there, no, for it not to move. And also, no, friction, no, is a contact force. No? So as I've mentioned the word contact force earlier, no? So you really have to be in contact with one surface. No? So we can have, no, this contact force present. No? So friction could never, no, occur at a given distance. No? So it has to be, no, in contact with one another. No? Now, when we think of friction, also, no, friction is a kind of a force that is relative, no, to the motion of the motion of the object. No? So when I say relative, it tends to act, no, opposite the direction of the motion of an object. No? So if you are sliding, for example, a box, no, earlier, no, if you slide it to the right, frictional force will tend to move in the other direction. No? It will be going left. No? If you move the object, if you slide the object to the left, then friction will relatively change its direction also. No? So the direction of the frictional force depends on where you are actually dragging an object. No? So how do we then describe friction in our own language, for example? So friction could be considered as a kind of a force that is relatively opposite the direction of the motion of the object. So again, if we see this block here, this white box here, we use an applied force F. So I call big letter F here as an applied force, maybe a tension. No? Now the motion, since it's going to the right, will cause frictional force to be moving left. And actually now we have some notation here, FK, Fs, and it speaks about a state where the body is when we consider some values or some notations called Fs or Fk. Now Fk here refers to what they call as kinetic friction. Now kinetic friction, from the word kinetic, refers to a kind of friction when the body is already in motion. So actually now there are two types of friction that we can consider now. One that we call a static friction or static frictional force, and then another one which is called as kinetic friction. Kinetic friction or kinetic frictional force is a kind of a frictional force when bodies are in motion, when it is sliding. Or another word for kinetic friction is called as a sliding friction. So those are those two kinds of frictional forces depends on the state of the body. Now the word static usually refers when a body is not in motion, when it is at rest, literally at rest. So here's a lady or a person pushing the object to the right. I don't know. Maybe this is a sliding door. So the sliding door, if you have a gate also, there are some metal or steel gates that are being slide, or when you close it, you have to slide it from the wall. So friction will be present on the surfaces that are moving, and it is in the other direction when we try to slide the object. So look at the direction of the motion. Frictional force is moving opposite that direction. Now, I thought I mentioned about some things that are good about friction. So one that I mentioned is we are able to move or able to travel from point A to point B, like a car, like when we walk, when we ride our bicycle, we are able to travel from A to B because of the presence of friction. So, but let's see some other advantages of friction. So if it were not for friction between the shoe and the floor, people would have great difficulty in moving. It is difficult to walk on a very slippery surface where frictional force is very small. Like I think in some countries where there's snow or there's winter, they always have this problem on the road where the road gets very, very slippery. I think they have the word there called hydroplaning. When you drive your car and when your car starts to lose control, and it simply slides, and the driver there, even though he's running at a very slow motion or slow speed, that still occurs. And again, when you lose control of your car, of course, you can bump on other vehicles or accidents can literally happen. So again, those things are possible when there's no friction anymore. Or when we walk on our, or when we step on our bathroom and our bathroom tiles are wet and we slip, we will get injured if we will slip. So if these are elderly persons that slip on bathroom floors, usually they get what, no? Say their age is 60 and above, no? And when they have this injuries, no, behind their back, no, like a bone injury, then maybe no, they will it will render them no, what, no, injured for life, no, for the remainder of their life. No? Again, no, for people who are older, no, sleeping on a bathroom, no, is not a very good thing. No? So again, no, slippery floors. No, we try to avoid that. No? We also have no, some restaurants. No, when the floors are mopped. No, you notice that in these restaurants they always put a sign. No, that it's wet, and it's just but a reminder to everyone that somebody is working and the tiled floor no is wet, and you have to be cautious when you walk there. No? Again, no, again, these are things that are not good. No? Okay, let's go to number two. No, item two. So for motion, no, is one advantage of friction. Now, in starting a car, no, from rest, so maybe now friction is present. No? When a car turns no, around a curve, no, so we are able to make a perfect turn no? Because the tires of the car will hold no? When you spin. So you are able to make a turn no? On a rotonda no? Because of that. No? Otherwise, no? Or if the road is not banked, no? We notice that some curb roads, guys, no? You'll see that when you make a turn, it's kind of slopey, no? Medyo mayara na siyang banking angle. Kung mag-agi ka mo sa likuon, no? So it seems that your car is if the road, no? It seems that the road is not level, no? It's purposely made, no, or designed, no, kung mag-agi ka sa likuon, no? And especially if these curb roads, no, are the cars that are moving there are moving fast. So ginabank na nila may ara na sa certain angle. No? So the banking there is for reasons not to provide a greater amount of friction no? For cars that will make the turn. No? So it's not an engineering no mistake no that they have that road there no nga nagahilay na sa mga likuon. No? So it's a design of the road for safety. No? So like this I think no mga race cars no. So you'll see that if these are fast moving cars no they have they made some of these roads bank. No? So when we drive also belts no so this is the motor probably no, and this is a device that has to be moved. And the belts there now has a greater amount of friction, and usually the materials that are used there now are materials that are purposely now paired together now that really gives us with greater friction. Usually the belts are made of rubber no? Rubberized material no? Some rubber materials are what no? They are natural rubber, but usually natural rubber is a material that is easily damaged by many liquids, no? Like oil. No? They are immediately not damaged by oil. But if they build a synthetic kind of rubber, no, which they call as elastomers, no? Elastomers are a kind of rubber that is actually no near or very close to plastics already, and these are materials that can withstand no? Many kinds of liquids, and then they are not easily damaged. No? So belts, no, rubber belts, no, that drives motors and another thing, no, are very helpful devices. No? So we see this now sometimes in our compressor. No? So if you have some equipments in your house, no, that are considered no, compressors, the one that they use to clean the car. No? So they have these belts that you see. No? It is needed in holding objects by means of nails or screws. So we fasten things. No? Now, what are disadvantages of friction? So if friction provides us with so many useful things or advantages, there are also some things when it's too much, that friction also is not favorable to us. No? So again, like the wearing down of parts, like this. I think this is a piston. So a piston, when it's too hot, when you put pistons are placed in our car engines. So if you are familiar with your car engines, the part there that allows your tire to move is this piston that is fired when the engine is running. Now, when you forget to put an oil into the car, so if your uh, engine oil is way below the normal level that is usually checked. So if you forget to fill it up with the right amount of oil, then what will happen to your car? Your car will overheat. Overheating will cause damage to this piston. So piston has to be lubricated to be able to function well. But when there's too much friction there, it will cause your engine to break. So you see metals when they are heated, they expand. When they expand so much, then that's what happens when your engine breaks. So we don't want our engine to stay so hot. So mayroon na siya cooling system. There's water there. There's oil to prevent it from heating up because of friction. Now, tires, we see that our tire nagakaupod na siya, ang aton sapatos, there's wearing of our shoes. When I say wearing, nagaupod siya. So when you walk, when you use your shoes, then naturally, mabakal hagid sang bago. Hindi pwede nga ang imo sapatos na ginausar has been there for 50 or 20 years. Kay that's not the natural design of a shoes. So maybe the longest that you could use your shoes will be 5 years, and I think that's already too long. If you use your shoes. Now again, number 2, it increases the effort necessary to operate any kind of mechanical devices, and therefore reduces the efficiency of machines. So when there's less friction, when there should have been less friction, then maybe we could have a much more efficient devices. But again, reality-wise, it's impossible to have a device that is completely frictionless. So there's always an amount of friction. But we are able to minimize it by uses of oil, grease. We are able to reduce the amount of friction there. Now, it produces heat by converting mechanical energy into heat. So when things are rubbed, let's say when you feel cold, what do you do with your palm? You rub your palm together. And in some way, that gives you some amounts of heat when it's during the cold season. So those are some ways where we can also generate heat by rubbing things together or rubbing our palm together. But again, not too much heat or too much friction can be also not good. It can accelerate the wearing down of parts. Now, if we need friction, then how do we increase the amount of friction? So here are some suggestions. Okay, so when we pair together rubber and concrete, so like the one that we use for the tire of a vehicle. Now, why is it that we always have a rubber and we don't use other materials for our tire? Now, rubber and concrete or cement these are the best pairs of materials that will achieve the highest amount of friction. I have not seen yet a material that goes beyond the functions or use of a rubber for our tire. because those pairs of materials now provide the highest amounts of friction. Now we roughen the surface. Now we don't see no roads that are made of tiles. No, we don't tile our roads. No, so it's highly unlikely that we will do that. No, because it will just cause no more no people no being run over probably no when there's a need for you to stop. No? Now snow chains. No, so for the road, we don't have that in the Philippines. No, but in countries where there's winter, no, they put chains no, on the tire to increase the friction, or they use spikes. No? So you'll see some people that are wearing these shoes, guys. No, there are spikes there, no, to prevent you from slipping also. No, so football players, no, those that play golf, no, they have some spike shoes. No, now ways to reduce friction also. No, when we need not to improve some functionalities, no, like machines, then we use these things, no, lubricants. No, lubricants includes oil, grease, no? Even our water no, is also a kind of useful lubricant. No? Now we should smoothen the surface. No? You use you use a what? No? A tiled floor, no? A glass. No? So it's smoother no? Than a concrete. No? So for example, our classrooms, if in a face-to-face class you are staying in a classroom that is paved no with only concrete, I think uh when we walk on concrete no, we will have more wearing down of our shoes. No, but usually no, our homes, our schools no, they are tiled not to also not to minimize the damage on our shoes and make also the surface look good. No, so smoothen the surface reduces friction. No? Suppositories, these are devices when we have constipation. No? So when people gets constipated no, over time, they apply these lubricants no, for you to easily no, remove your bowel. No? So suppositories. No? So these are also no, probably we can think of it as a kind of a lubricant no, or a way to no, remove your trapped bowel. No? Bearings are used in our machines. No? So those are metal balls, or I think no metal cylinders that, when paired with grease, no, can improve no the movement of parts that are rotating. No? So in your bicycle, those parts that move together, there are bearings there, no, very tiny metal balls, no, and they are no maybe not looking like this, no. So these are tiny metal balls here with some kind of a grease, no, grasa, so that when it spins, no, it lessens the amount of frictions on parts that are in contact. No? Okay, let's look at some factors also no, that affects the amount of friction. No? And we'll be naming, I think, five of these factors. No? I think two of these factors are relatively no, independent of the amount of friction. Now, the first one that will really have no, an effect on friction is the nature of a surface. No? So by nature of the surface, no, we have greater friction when the surface is rough, no? And lesser friction probably no, when no, the surface is smooth. Now look at the length of the frictional force, no, Fk. When it's rough, no, it's quite longer, no, ang arrow, because there's greater frictional force, no, when the surface is rough. No? Now, another factor that we could also no, think of, no, so rough surfaces again no, provides us with greater amounts of friction. So this is again no, the kind of surface that we have. No? Rubber, for example, no? The kind of material that you are using there, no? Rubber versus plastic. No? Rubber materials will have a greater amount of friction. No? There are people, guys, that are what no? Intubated, or there are people who are fed no? By using this nasogastral tube, no? Inang ginasulod sa ilong sang pasyente bala, no? Now, I think today, no, that's made of silicone plastic, no? Because I think, no, way back, there was a time when the one that they insert on the nose, no, going to the stomach of the person, especially if the person cannot eat anymore, no, on its own, or if the tendency of the person, no, is to choke, no, salamukan siya, no, kung magkaon pa siya bala kay nagatalang ng pagkaon nagakadto siya baga, no. You notice in our I think, no, in our throat or somewhere in our digestive tract there, no, na mayroon na sphincter nga nagasira, no, when you're eating, no, and when it transfers, no, kung gusto ka maginhawa naman, that same sphincter, no, allows air, no, to get in, but it closes, no, when you are eating food, no, so that food will go to your stomach and air will go to your lungs, no. But when this part of our body malfunctions, then it's possible that when you're eating something, no, that food, instead of going to your stomach, will go to your lungs, no. Now, to avoid that, no, people are fed, no, by a kind of a tube, no, that passes your nose and gets to your stomach, no. Now, what they do is that when it is inserted in your body, no, that tube, no, that's a very long tube, no, they will try to push it, no, in one straight motion, no. So once they start the process of inserting the tube in your body or in your nose, no, that process has to be done, no, in one straight motion. Hindi pwede nga pag abot sa tunga-tunga mauntat siya kag ilusot naman liwat, no, because it will be very painful, no. So to also minimize the amount of friction there, no, I think way back, no, they are using rubber there, no, to insert it in your body, no. No, but I think right now, no, what is used is a silicone plastic, no. I think silicone plastic will have lesser friction, and again, no, it's inserted from the nose, no, until it reaches the stomach, no, and food is already, no, in liquid, no, or in suspension form, and gina-press na lang siya sa ilong mo, no, whenever you are fed, no, your meal, no. Okay, so because again, no, kung magkaon kapabi, no, may mga tao nga magkaon nagatalang ang pagkaon, so to avoid the person, no, nga masalamukan siya or mapatay siya because of the food nga nagtalang, no, amo na ang ginagamit, no? But again, no, the point is about friction, no? So instead of using rubber materials, no, they use a plastic material, no, to have that, no? So the nature of the surface, no? Now next is the state of the body, no? Now if a body is at rest, there's greater friction when a body is at rest, no? Now just imagine this car, guys, no? This car, if it will not run, no, you will probably ask persons to push it, no, and some usual methods that we do when we push a body, usually, no, or a car, no, we are able to start it up, no, by letting some few individuals push it around, no, and you start it up, no. Now usually when it starts from rest, you'll need more people, no? Now, but however, once this car is already moving, no, you'll notice that the initial 5 people that started pushing it, no, may be reduced to 3, no, or to 2 people, and to 2 individuals already, no, once the car is already sliding forward, no. Now, but you cannot do that now when the car is completely at rest, no. You will need more people, no, to push this when it is at rest than when it is in motion. So again, no, the nature of the body or the state of the body when it is at rest, there's greater friction here, no? Now we call the friction present when the body is at rest as static friction. We label it as F sub S, no? F sub S, S being static, no? So static means the body is at rest, no? So static friction is bigger, no, when the body is not in motion, no? Now when the body is moving, no, so like this one, no, so maybe, no, less people now is being used, no, to or is pushing the car, no, to make it move because it's already sliding, no? Now, the kind of friction present when it is already moving is known as kinetic friction. Okay, kinetic friction is present now when it's moving, and there's lesser kinetic friction. So Fs usually is higher. It is a greater value than Fk. Okay, so again, the state of the body. So when the body is at rest or when it is in motion, there are two different amounts of frictional force present. Now, next is the normal pressure or the normal force. We call it as the total normal pressure or the normal force. And we label it commonly as letter N. Others would call it F sub N. But we can just simply say big letter N. Big letter N or the normal force is a kind of force that is directed usually perpendicular to the surface of the plane. So for example, you put an object here. So object 1 is placed on a table. Now, surface of object 1 will come in contact to surface 2 of the table. And once they are in contact with one another, then a force will now occur. Now, the downward force is known as weight. So this green box will always have a weight that goes downward. However, when this weight goes down, a reaction will occur. So from our Newton's third law, we see that for every action, like a weight pressing on a table, there will always be a reaction that is equal in magnitude, but opposite in direction. So the normal force that results when weight is pressed downward is an action-reaction thing. Now, what we notice is that when this normal force, that is a reaction of a table, happens to be bigger, what they notice is that when N or normal force is increased, frictional force also increases. So there's a kind of direct relationship between friction and normal force. Bigger frictional force now results when there is a greater normal force. Now, since they are proportional to one another, we can remove the proportionality and make it an equal or an equation by adding a constant. Now, that constant is what we call as the coefficient of friction. Now, if it is in motion, if it's a kind of friction which is in motion, then we could use here kinetic friction. But when it is static, or when it's not moving, then we will have static friction as well. So mu sub k may be called mu sub k or mu sub s, depending on whether it's static coefficient or kinetic coefficient of friction. So depende. But again, friction and normal force are directly proportional to one another. Meaning, again, bigger normal force will result to greater frictional force. So that's the third factor. So again, let's recall. What are these three factors so far? Number one is nature of the surface or nature of the material that you have, like rubber versus plastic. There's always greater frictional force. A rough surface over a smooth surface. So they will always have a different amount of friction. Number two is state of the body, whether the body is at rest or in motion. And finally, the normal force or the total normal pressure. So these are things that affects our degree of frictional force. So W here is our weight, which is of course M times G. But since N is a natural reaction of G, in this illustration, then our N and G actually are our weight and the N are actually equal to one another. Okay, here's a sample problem about frictional force. and we will probably discuss that in a short while.